So motion in one dimension. So there are different kinds of motions. Okay, before we start with the motion, we'll just look into the vector and scalar quantities. So there are two types of physical quantities. Scalar quantity is a physical quantity which needs only magnitude. So motion in one dimension. So just there are different kinds of motions. Okay, before we start with the motion, we'll just look into the vector and scalar quantities. So there are two types of physical quantities. Scalar quantity is a physical quantity which needs okay. So we have two types of physical quantities, scalar quantity and vector quantity. Now, what are the scalar quantities? So these quantities, can you hear me?
Yes.
Okay.
Yes.
So the scalar quantities are those physical quantities which can be expressed only by their magnitude. You don't need any direction to express them. So you need just magnitude and a unit. So a numerical value and a unit. In chapter 1, we have studied how to express any quantity. So to express any quantity, we need a numerical value and we need a unit. For example, if I tell you to get potatoes, so definitely you will ask me how many kgs. So you need a numerical value, 5 kg, 2 kg, 3 kg. So there is a numerical value and a unit. So such quantities which require only magnitude to express themselves, they are called scalar quantities. So mass, length, time, distance, density, volume, speed, temperature, work, energy, charge, all these are examples of scalar quantity. There are other physical quantities. They require a direction as well as to their magnitude. That means you have to show whether it is going in the north direction, east direction, south, west, whatever. So these quantities are incomplete without directions. And such quantities are called vector quantities. So vector quantities are those quantities which require magnitude as well as direction to express themselves. The numerical unit, value unit, and direction. So direction is required. For example, displacement. So when I say a boy is moving 2 kilometers, so then the question will be asked in which direction. So I say the boy is moving 2 kilometers north. Then you can say, okay, the displacement is 2 kilometers towards the north. Okay. For distance, we do not require direction. So if I say the boy cycling for 2 kilometers, so okay, it's a distance 2 kilometers, so you don't require any direction. Similarly, velocity requires direction, speed does not require direction. Acceleration requires direction. Okay. Momentum, force, moment of force, impulse, weight, magnetic field, all these, they require direction to express themselves. So there are two types of quantities, physical quantities, scalar and vector. Okay. So can you tell me a physical quantity which will require direction? Any physical quantity that comes to your mind?
Displacement vector quantity.
Displacement vector quantity. Okay. Any scalar quantity which you can think of?
Distance.
Distance. Okay. So now we will start with the motion in one dimension. So first of all, motion and rest. So they are relative terms. Why they are relative terms? Because we relate with the immediate surrounding. So you are sitting at your place, at your home, so you are at rest. But if someone from the space looks at you through satellite, so then what happens? You are moving along with the earth, isn't it? So you are in motion as well. So But what we see is that immediate surrounding. If just you look around your surrounding, okay, your position is not changing with your immediate surrounding, so you are at rest. So when a passenger train is moving, so the passengers which are sitting inside the train, they are at rest with each other. But someone who is standing out, for them, the entire train is moving. Okay, so the train is in motion. So that is why we say that these rest and motion, these terms are relative. So a body is said to be at rest when it does not change its position with respect to immediate surrounding. With respect to immediate surrounding is important. And when it changes its position with respect to immediate surrounding, then it is said to be in motion. Clear?
Yes.
So if you are asked for an example, so we can say that the passengers sitting side by side in a moving train are at rest with each other. Or a book kept on the table is at rest. But a train which is moving in front of any passenger is in motion. In front of any observer is in motion. Or a merry-go-round, it is in motion, right? Or a moving car, so it's in motion. Okay. Or a boy who is running or cycling, he is in motion.
Motion.
So is the concept clear? Motion and rest?
Yes.
So these are something with the motion and rest. Now, one-dimensional motion. What do you mean by one-dimensional motion? So motion along a straight line path is called rectilinear motion or one-dimensional motion. So a car moving on a straight road, or the train on a straight track, a ball falling down. So all these are one-dimensional motion. So there is a change in only one axis with the time. With the time, only one axis changes, and so that is one-dimensional motion. Now, two-dimensional motion, it is along a curve or a circular path. So if you see that the x-axis also changes, y-axis also. So it is two-dimensional motion. Okay, so when an aeroplane takes off, just visualize an aeroplane taking off. When an aeroplane is taking off, you see the height also increases and the distance from the start point also increases. Both are changing. So that is two-dimensional motion. But at a certain point, when it stabilizes at a height and it is going straight forward, then it turns into a one-dimensional. Are you getting the point? Two-dimensional and one-dimensional?
Yes.
Okay. So a curve or a circular path, so it is a two-dimensional motion. Now, three-dimensional motion. So in this, the three, length, breadth, and depth, all are changing. Okay, three-dimensional motion. So unit of three-dimensional motion, so the motion in a space, that is a three-dimensional motion. So that is also like if a butterfly is moving, okay? So, or as I told you, when the aeroplane is moving, its z-axis is also changing. That is height, length, and the width, everything is changing. So that is the three-dimensional motion. Change of x, y, and z axis. So in our portion, we have just one-dimensional motion, that is the rectilinear motion or a motion along a straight line path. Okay, so motion along a straight line path, one-dimensional motion, motion along a circular path, it's a two-dimensional motion, and motion in a space is three-dimensional motion. Okay, now displacement versus distance. Now, when we are moving along a straight line path, the actual length traveled is the distance traveled. Actual length traveled is the distance traveled. For example, if I move to a distance of 8 meters north, and then I move to a distance of 2 meters west, then my total distance is 10 meters without any change in that, without any direction. So that is the actual path traveled. So that is the distance. It's the actual path. Okay. So the total length of the path of that object, which a body travels or the object travels, is called the distance. Whereas the shortest path between the start point and the end point is known as displacement, and displacement requires the direction as well. Displacement requires the direction as well. Okay, so if someone is moving 5 meters forward and 3 meters backward, so the net distance is now 2 meters. So that is the displacement of 2 meters from the start point. Okay, for example, if so suppose a boy is moving north 3 meters and then moving east 4 meters. So the displacement here will be 5 meters by Pythagoras theorem. And the direction will be northeast. Clear? Any doubt?
No.
So this is to define distance and displacement. So a person is moving in a zigzag manner. So from A to B, the total distance will be this dotted line, the length of the dotted line, whereas the displacement will be the straight line path from A to B. Now this is very important. Okay, tell me, as you have done this chapter in school, can you tell me, like, if there is a small, okay, there is a boy. There's a boy at the point A. He is cycling. And let's say the radius of this is circular path is 7 meters. Okay, the radius of the circular path is 7 meters. So the boy travels from A to B exactly opposite. This B is a point exactly opposite to A. So can you tell me what is the distance traveled?
$14 meters.
Distance traveled, what do you say? How do have I hope you have done circles in class 8. So what is the circumference of the circle? It is going in this way, right? This is the way he will go.
Yes.
The circular path. So what will be the distance traveled? What's the formula for circumference of the circle?
I don't know. Pi is 2 pi r.
Correct, 2 pi r. So it is half circle, so only pi r, right? So it becomes how much?
22 upon 7 into 7.
So it becomes how much?
22.
And now if I ask you what is the displacement, so we'll see the shortest distance. So that is the diameter. So the displacement is how much?
$14 meters.
40. So is the concept clear for the distance and the displacement?
Yes.
Let's see the differences. So distance and the displacement. So distance, the length of the actual path traveled, whereas the displacement is the shortest part between the initial and the final position of the body. Distance is a scalar quantity. Displacement is a vector quantity. Distance is always positive. You cannot have a negative distance. But the displacement can be positive or negative. can be more than or equal to the magnitude of the displacement. Displacement can never be more than the magnitude of the distance. It can be equal to the magnitude of the distance at most. Distance can never be zero. Displacement can be zero for the bodies going back to the original position. Let us go back to the previous one. Now, this boy cycled the entire thing and came back to the original position A. So when he comes back to the original position A, now the distance traveled will be 2 pi r.
Yes.
So that means 44 meters. Whereas the displacement will be zero.
As he's coming back from A to B and from B to A.
Yes, as he has come back to the original position. So when the displacement can be zero, the displacement can be negative. Now, how the displacement can be negative? Let us see, this is a place A. From here, a boy starts moving forward, goes to a place B. Let's say it is 5 kilometers north. After finishing his work from the point B, he goes back on the backside of his house to a point C, which is 1 kilometer from here. So now at this point, his displacement is negative 1 kilometer.
Yes, so it will be 4 kilometers.
So displacement can be negative. The displacement can be positive. The displacement can be zero. But the distance will be always positive. If I talk about the distance, so we will say he has gone 5 kilometers, and 1 kilometer. So total distance traveled is 11 kilometers. 5 going, 5 coming back, and 1 behind his house. Okay, so distance can never be negative. If a body is stationary, the distance can be zero. But the distance can never be less than the displacement. It can never be less than displacement. It will be at most, at least, it will be equal to the displacement. Whereas the displacement can be at most to the distance. So if a boy is cycling and he moves 11 kilometers to a point B from A along a straight line path, so the distance traveled is 11 kilometer, displacement is also 11 north or east, whatever. So displacement, so are the things clear?
Yes.
So the distance and displacement, so the difference, number one, so distance is a scalar quantity, displacement is a vector quantity. Distance is the length of the actual path traveled by the body, whereas the displacement is the length of the shortest path between the initial position and the final position of the body. Distance is always positive. It can be positive or negative or zero. And distance can be more than or equal to the magnitude of the displacement, whereas the displacement can never be displacement can never be more than the magnitude of the distance. Distance can never be zero for a moving body. Displacement can be zero if the body goes back to the original position. Okay. Now, speed. Speed is the distance per unit time or the distance traveled in the unit time. So we have uniform speed if equal distance is traveled in equal intervals of time. So for example, 50 meters in 1 minute, every time the boy is cycling at a speed of 50 meters per minute. So per minute, so that the boy is moving with a uniform speed. Non-uniform speed, equal distance in equal interval of time. Unequal interval of time. Unequal distance in equal interval. By both the ways, vice versa. Again, I'm saying unequal distance. Are you there?
you
Yeah.
repeat?
Yeah. So for uniform speed is clear to you, Anya?
Can you repeat because the video was stopped?
Okay. So uniform speed is equal distance in equal interval of time. So when a boy is cycling 50 meters per second, for every second, he is moving a distance of 50 meters. So he is moving with a uniform speed that is 50 meters per second or 50 meters per minute, whatever it is. But if the distance is equal, but the time interval is unequal, or if the distance is unequal and the time interval is equal, the body is said to be moving with non-uniform speed. That is unequal distance in equal time interval. Look at this bus, school bus. So in 1 second, it is covering 10 meters. In another second, it is covering 15 meters. In the next second, it is covering 5 meters. So unequal distance in equal interval. So that is non-uniform speed. Clear?
Okay.
Now, when a body moves with uniform speed at any point of the time, the speed will be constant. So there is no change in the speed. है ना? अगर वो 50 मीटर पर सेकंड की स्पीड से जा रहा है, so every time चाहे आप उसको 5th सेकंड में देखो, 4th सेकंड में देखो, 10th सेकंड में देखो, वो 50 मीटर ही कवर करेगा every second. So the boy is moving with a uniform speed. But प्रॉब्लम कब आती है? तब जैसे ये बस की बात कर रहे हैं. लुक एट दिस बस. 1 सेकंड में उसने 10 मीटर कवर किया, दूसरे सेकंड में उसने 15 कवर किया, तीसरे सेकंड में 5 कवर किया. So in this condition, what happens? There is an instantaneous speed. अगर मैंने आपको पूछा कि at the end of the second, what is the speed? तो स्पीड आप बोलोगे 15 मीटर पर सेकंड. सेकंड में. थर्ड सेकंड में कितना हो गया? 5 meter per second. The speed is changing. Are you getting my point, Anya? Speed कैसे
Yes. Yes.
So the instantaneous speed plays the role only when we have non-uniform motion. Uniform motion में तो instantaneous speed same ही रहेगी. Every time it will remain same. It will remain same, constant. Okay, so when a body is moving with variable speed, then the speed at any distance is called instantaneous speed. Okay, so if it is asked at the end of the 4th second or at the end of the 5th second, so you can find out the speed from the graph. Now, average speed is total distance upon total time. That is called average speed. Total distance upon total time. So when a body moves with a uniform speed, then the instantaneous and average speeds are equal. All clear?
Yes.
Now speed versus velocity. Speed is simply how fast you are traveling. Distance upon time. But the velocity is speed in a particular direction. Okay, so when I say a car is moving with a speed of 10 meters per second, so you say that, okay, fine, the car is moving, but you do not have the direction. But as soon as I say the car is moving at a speed of 10 meters per second north, so you get, oh, you have a direction, so matlab car is moving towards the north, and so that is the velocity. So the difference between speed and velocity is that the velocity needs a direction. The velocity needs a direction. So speed with a specified direction becomes velocity. Velocity without direction remains speed.
Okay.
Okay. Now, velocity is, in actual sense, it is displacement upon time. That is distance traveled per unit time in a particular direction. So uniform velocity, equal distance in a particular direction in equal interval of time. Now here we have 3 things to notice. equal distance, fixed direction, equal interval. So if any one changes, it will become non-uniform. If I change unequal distance in a particular direction in equal interval of time, it's non-uniform. If I change equal distance in different direction in equal interval of time, it is again non-uniform. Okay, so we have three factors. So equal distance in a particular direction, but in unequal interval of time, so again it is a non-uniform. Okay, so uniform velocity means equal distance in equal interval of time in a particular direction. So that is uniform velocity. And the classical example, this is very, very important. Raindrops falling down. Did your teacher in your school explain that how raindrops falling down is an example of uniform velocity?
No, ma'am.
Okay. Now, this is a very important concept to understand. आप जनरली देखो कोई भी चीज ऊपर से गिरेगी तो उसकी वेलोसिटी इंक्रीज होगी. आपने देखा आपने ऊपर से ड्रॉप किया तो वो जीरो वेलोसिटी पे था the moment you drop, but as soon as it touches the ground, it touches the ground with the maximum velocity. है ना? So अभी raindrops में ऐसा क्यों नहीं होता है? The reason is that when the raindrops are coming from a distance, there are two factors working on it. Number one, the gravitational pull of the earth, which is pulling it down, applying the force in the downward direction to increase the velocity. Acceleration, it is applying acceleration to increase the velocity. Whereas there is a viscous force and air friction. There is a viscous force. Liquids में क्या होता है? In liquids, there are layers which are moving against each other. आप देखो पानी pour करो और honey pour करो. पानी फटाफट गिर जाएगा, हनी थोड़ा धीरे धीरे गिरेगा. Correct? The viscous force between the layers of the honey particles is high, and the viscous force between the layers of the water particles is less. But there is a viscous force. This force, the viscous force, is the force between the layers of the liquid. Okay, so when the raindrops are falling down, there is a viscous force acting, and this viscous force compensates the acceleration due to gravity, or the acceleration force due to acceleration due to gravity. So force, there is, just see this, there is a raindrop falling. So this is the gravitational force acting here down, and I'll put a F gravity, and there is a viscous force acting in the upward direction, FB, and they nullify each other. They are exactly equal, and so they nullify each other, and there is no, the net force is zero. And so it comes with its uniform velocity. Clear?
Yes.
Electrons revolving, they are also an uniform velocity. Okay, uniform velocity. So these are the classical examples. Now, non-uniform or variable velocity, unequal distance in equal or equal distance in different direction in equal interval of time. So either the unequal distance or equal distance in different direction. So equal distance in the same direction, unequal distance in the same direction, or equal distance in different direction. Unequal distance or equal distance in same direction or unequal or different direction. then that will form non-uniform velocity. So one thing should be changing out of the three parameters, either the distance or the direction or the time interval. All the three cannot remain constant. अगर equal distance है तो आपका direction change होना चाहिए या फिर time interval change होना चाहिए. So that is called non-uniform velocity. Clear?
Okay.
Now, again, since it is non-uniform velocity, we will have instantaneous velocity. Uniform velocity means everything remains constant, so the instantaneous velocity also remains constant. But only in the case of non-uniform velocity, we have instantaneous velocity. So velocity at any particular instant will be the instantaneous velocity. So the example of a body moving with uniform speed but variable velocity. So this is a classical example of a body in a circular motion. So the speed is constant, but the velocity changes because of the change in direction. Look at this one. So this is the center of the circle, and this is the acceleration is always inward towards the center. This is called centripetal force, and centripetal force produces an acceleration inward. And so the body is moving, changing its direction every moment. So this is an example of a body moving with uniform speed but variable velocity. The velocity is changing because of the change in direction. Okay. Did you do this example in school?
We did not do instantaneous velocity.
Oh. Now, example of body moving with uniform speed but variable velocity. So body falling freely under gravity, the speed also changes and velocity also changes. Because under the gravity, always what happens? The velocity is increasing. Average velocity, total displacement upon total time. Average velocity. So difference between speed and velocity. So distance traveled per second by a body and distance traveled per second by a body in a particular direction, then it becomes velocity. Speed is a scalar quantity, velocity is a vector quantity. Speed is always positive, velocity can be positive, negative, or zero. If a body is falling down, okay, so it is towards the acceleration. So then it will have a positive speed, velocity. But if a body is going up, it will have a negative velocity. Along a circular path, the average speed is always zero, because average speed is not zero, because there is a distance traveled, but the velocity will be always zero, because in a circular path, the displacement becomes zero. If one covers the entire circle, then the displacement becomes zero, and so the average velocity becomes zero. This is very important, which I have already discussed with you. Can I complete the acceleration, or it's too much for you?
We can complete.
Okay, good. So acceleration is the rate of change of velocity with time. If the velocity decreases, then it is the retardation. And if velocity keeps on increasing, then it is acceleration. So acceleration is rate of change of velocity with time. That means what? Change in velocity upon the time. So this is the change in velocity. V is the final velocity, U is the initial velocity. So V minus U upon T becomes acceleration. Acceleration, since it is change in velocity, it's a vector quantity. And unit will be meter per second square. Let's talk about that. So uniform acceleration, equal changes in velocity in equal time interval. That is uniform acceleration. Variable acceleration, unequal changes in velocity equal time. So for example, if a body is moving with a velocity 2 meter per second and it changes to 4 meter per second, 4 meter per second in 1 second, and then another second changes to 6 meter per second. So now the change here is 2 meter per second square, and here also it is 2 meter per second square. So this is called uniform change. And so when this is a uniform change, the acceleration is uniform. But for example, the same body is moving with 2 meter per second, changing to 4 meter per second in 1 second. So this is 2 meter per second square is the acceleration, changes to 5 meter per second. So this is the change here from here to here is 1 meter per second square. So this acceleration is non-uniform. This acceleration is non-uniform. Clear?
If this is non-uniform, then it is retardation.
It is not retardation yet. There is an increase in velocity.
Okay.
But now, let's see the same thing. Now this boy is moving with 5 meter per second. And the next moment, it comes to rest, 0. So now, after 2 seconds, suppose it is coming to rest. So now the velocity becomes 0 minus 5 upon 2. Acceleration becomes 0 minus 5 upon 2. So that is minus 2.5 meter s minus 2. So now this is retardation. Negative acceleration is retardation. So when a body comes to rest, it is retarding. When a body slows down, it is retarding. When a body speeds up, it is accelerating. Clear है Anya?
Yes.
तो वेरिएबल वेलोसिटी भी क्लियर है, एक्सेलरेशन क्लियर हो गया. जब यहाँ पे 2 मीटर पर सेकेंड हो रहा है, यहाँ पे 1 मीटर पर सेकेंड हो रहा है. Correct?
Yes.
So this is variable. But here we have 2 meter per second square. Here also we have 2 meters per second square.
It is uniform.
Uniform. Acceleration due to gravity. We have been speaking about this quite a bit of time. जब मैंने raindrops की बात की थी, या फिर जब मैंने बोला body falling freely down, तब भी acceleration due to gravity is acting. So what is this acceleration due to gravity? Earth attracts everything towards its center, and that force of gravitational force is due to the Earth's pull is called the gravitational force due to the Earth's gravitational force. There is an acceleration created, and that acceleration is called acceleration due to gravity. Acceleration anytime happens whenever there is a force acting on a body. और जब force कौन सा होता है, gravitational pull का force होगा, then that acceleration produced will be called acceleration due to gravity. Okay, so when a body is falling down, it is under the impact of acceleration due to gravity. Because had not there been any force towards the Earth center, the body would have gone out in the space. But it is not happening. The body is coming towards the Earth because there is a pull towards the Earth's surface. And because of this pull, there is an acceleration produced, and that acceleration is called acceleration due to gravity. So when a body falls freely under gravity, the acceleration produced on the body due to Earth's gravitational pull is called acceleration due to gravity. It is denoted by small g. The average value is 9.8 meter per second square. G does not depend upon the mass of the body. G is independent of the mass of the body. तो अगर एक feather और एक ball को एक साथ हमने वैक्यूम में ड्रॉप किया, वैक्यूम में, then both of them will reach the ground at the same time. Okay, क्योंकि the acceleration due to gravity is independent of the mass. But अगर दोनों ही को हमने atmosphere में drop किया, not in vacuum, then what will happen? There will be upstress acting on the feather, and the feather float करता जाएगा, and it will float, it will fall down at a different time. Ball will come down straight because there is minimum upthrust acting. ये हम upthrust के chapter में फिर से पढ़ने वाले. But just that you know it, that a feather and a ball drop from the same height in vacuum reaches ground at the same time as there is no air friction or upthrust acting on the body. Are you there, Anya? Anya?
Can you repeat because the video was
Yes. So acceleration due to gravity is the acceleration caused due to Earth's gravitational pull. So due to Earth's gravitational pull, there is a force acting, and this force causes acceleration in any body. And this acceleration is always towards the Earth's center. So it is taken G for the falling down body is positive. And it is denoted by this acceleration due to gravity is denoted by small g, and its average value is 9.8 meter per second square. Now, this acceleration due to gravity does not depend upon the mass of the body. It is not like that. The heavier is the mass, the more is the gravity. नहीं, ऐसा नहीं है. It is independent of the mass of the body. Okay. In general, अगर आप देखोगे कि जिस पे फोर्स आया, उस पे अगर बॉडी का मास ज्यादा प्रोड्यूस होता है. अगर आप एक वन डायमेंशनल मोशन की हम बात कर रहे हैं, अगर आप सोचिए कि एक आपके पास मार्बल है, आपने फोर्स लगाया, अगर वो मार्बल छोटा है वो बहुत स्पीड से जाएगा, अगर वो मार्बल बड़ा है वो कम स्पीड से जाएगा, है ना, क्योंकि इट इज डिपेंडिंग अपॉन द मास ऑफ द बॉडी. बट acceleration of gravity is independent of the mass. उसको कोई फर्क नहीं पड़ता whether body is heavy or whether the body is light. Okay, and this is shown by an experiment where feather and ball are dropped from the same height in vacuum. तो क्या होता है कि feather and ball they fall down at the same time. But अगर हम हवा में करेंगे, not in vacuum, if we do it in atmosphere like that, the feather will float and come down slowly, whereas the ball will come faster. Because here another factor is acting, that is the upthrust. And that we are going to study in the chapter 5. Okay, so is this part clear that feather and ball, when dropped from the same height in vacuum, will reach the ground at the same time because the mass does not affect the acceleration due to gravity. Okay. The last part, this we are going to do it again. This is we are going to do again in no, this is again we will be doing in the third chapter, but still I'll show you once here that this acceleration due to gravity is maximum at poles. Now, why it is maximum at poles? We know that what is the shape of the Earth? It's a geoid shape, right?
Yes.
Slightly flattened. Slightly flattened. It's not same. It is slightly flattened at the poles. So if I take from the center, if I take this distance r as the radius at equator, and this I take at the radius at the poles, so naturally the radius at the poles will be less than the radius at the equator, and so g at poles is more than g at equator. The acceleration due to gravity at poles is more than the acceleration due to gravity at equator. G is always maximum at the surface. If you go below the surface, it decreases. If you go above the surface, it decreases. So acceleration due to gravity in mines will be less than the acceleration due to gravity at the surface. Or at the seabed will be less than the acceleration due to gravity at the sea surface. Acceleration due to gravity at the mountain top will be less as compared to the base of the mountain. Okay, so this G is inversely proportional to the radius, and so G of the equator will be less than the G of the poles. This G, we are going to do this one more in the third chapter, as I told you. So G will be maximum at the surface of the earth and least below the surface or above the surface. At the earth's surface, it is maximum. Okay. So with this, we completed the first part. I just wanted to see whether we have mentioned. Okay, here. Distance is denoted by capital S, whereas the displacement is denoted by a capital S with an arrow. It's a vector quantity.
Okay.
So any doubt?
Why, in the last part, why gravity is more in the surface and not below the earth and
Okay.
up?
For this, I have to take you to the chapter 3. So I'll just briefly explain. This gravitational pull, the force due to gravity. F is the force due to gravity is directly proportional to the mass. And it is inversely proportional to the square of the distance between them, between the two bodies. Okay, so if we go down, look at this point. This we are going down. So now look at this will be the volume of the earth at this point. When we excavated, we went down in the mine. So this mass, look at this mass of this earth will be less, or this mass will be less. The entire big mass will be M, right? And now this new mass will be small. Correct? As we go down, the mass of the earth will decrease. Are you getting my point? Yes. So when the mass decreases, G decreases, F decreases. F decreases, G also decreases. Okay. So below the earth's surface, mass of the earth's surface decreases and G decreases. Above the earth's surface, distance increases. This distance will increase. So the distance increases and G decreases. Got it?
Yes.
So let us quickly go through . Let us quickly go through this. We did the term scalar and vector quantities. Any doubt in that?
No.
No. Then we know that how to write a unit, how to write any physical quantity, we need unit, the numerical value. And in case of vector quantity, we need direction. And in case of scalar quantity, we don't need direction. Then we discussed the rest and the motion thing. So they are relative. Okay. And then we discussed one-dimensional motion, two-dimensional motion, and three-dimensional motion. And then representation. So then we did the representation of 1, 2, and 3-dimensional motion. So that I'll be doing in the part 2. Okay. Now then we did the distance and displacement. So we also did that distance is a scalar quantity, displacement is a vector quantity. And we did the displacement can be 0 even if the distance is not 0, isn't it? Displacement, the magnitude of displacement can either be equal or less than the distance. So distance and displacement, we did the differences also. Then we did the speed and velocity, then the average speed, then average velocity. Then we did this example, that is the uniform velocity and variable velocity. And then we did this example, circular path is a constant speed but variable velocity. This is very important. Then we did the difference between speed and velocity, then acceleration and retardation. And then uniform acceleration, variable acceleration, and acceleration due to gravity. So all clear till here?
Yes.
Okay, so we stop for the physics right now. So what you will do is that go through this. Mostly I'll be sending you the PDF of that presentation. I'll send you the PDF. So you can go through that PDF. You can make a note on it. If anything is missing, you go through the textbook, write down whatever is missing in that. Okay, and then please go through the question answers at the end of the chapter, that part. So whatever you have doubt, see the answers you can mark in the PDF. Okay, and then whatever you do not know, you can ask me, and then we will complete the numericals.
Okay.
Okay. So we stop for the physics, take a quick break and come